Dear students, let's proceed with our lectures on the topic of application of operational method of Laplace transformation for solution of transient processes, for determination of transient processes in RLC, RL, RC circuits, and we have considered in previous lecture beginning of this topic. It's about transaction from function from time to function from p. In its presentation, function of time in the operational form. Its formula to get this operational image of some function of time, and let's apply this function we have applied it for several functions, for unit function, for exponential function, for such a function, and let's apply it also for sinusoidal function. We may write down sinusoidal function, we may rewrite it with the help of Euler's formula, or we may use here. It's a different way of for instance, with the help of Euler formula, we may rewrite it in such a form. Why? Because with the help of Euler formula, it will be sinus omega t plus j cosine omega t minus sinus from minus omega t. It will be 2 sinus omega t, and it will be minus cosine omega t, because sine is even function and cosine is odd sinus is odd function and cosine is even function. So cosine will be eliminated and we will get only sine, and it will be 2j sinus omega t, or we can express from here sinus omega t in such a way. But these formulas should be known to you also from mathematics when we write down the so-called hyperbolic functions. So, when we write down sinus in such a way, we can use linearity theorem. We can present such a function when we get its image by Laplace. We can write down at first this coefficient here, and then we should transact from such exponential function to its image by Laplace, and e in the degree minus alpha t can be presented as Laplace image in the form 1 over p plus alpha. So let's use this approach. It will be this function will be 1 over p plus alpha. Sorry, here it is minus, yes, and we can write down that it is minus j omega. So p plus alpha will be p minus j omega, okay? And next will be just this minus, then it will be just e is the minus alpha t, it will be, its image will be 1 over p plus alpha. So it will be 1 over p plus alpha here is j omega. So we have such an expression, and we can simplify it when writing down common denominator. It will be 2j here, and it will be product of these two denominators, of these two fractions. It will be p minus j omega multiplied by p plus j omega, and in numerator it will be this p plus j omega minus p minus j omega. So it will be minus p, minus and minus will give us plus j omega, and here we have p and p are eliminated, and we will have here 2j omega over 2j, it will be just omega, and here we have product of something like a minus b multiplied by a plus b. It will be it may be written as first item power 2 minus second item power 2. J omega in second degree equal to minus omega power 2, and minus will give us plus. So we have here p power 2 plus omega power 2. So we can write down that operational image of sinusoidal function, it is sign of operational equality equal to omega over p square 2 plus omega square 2. The same approach we can use to write down cosine function. You see, it may be written in such a form. Here also, if we apply Euler's theorem for this expression in brackets, we will have cosine omega t plus j sine omega t plus cosine minus j omega t equal to cosine omega t, and plus j sine minus j omega t, and sine omega t and minus sine omega t will be eliminated, and we will have here 2 cosine omega t over 2 equal just to cosine. Or it should be known, such an expression should be known to from mathematics. I just explaining how it may be got very easily. Let's calculate, obtain image by Laplace of this function of cosine, written in such a form, f from p. It will be equal, by the property of linearity, it will be equal to Laplace image of this function. Yes, it will be exponential function e in the degree minus alpha t. It's 1 over p plus alpha. So it will be 1 over p here, instead of minus j omega. So it will be minus j omega here. And here it will be just 1 plus p plus j omega, because minus is already here. Then, like in previous case, we have common denominator, and here it will be p plus j omega plus p minus j omega. J omega and j omega will be eliminated, and we will have here 2p over 2 is just p. So, Laplace image of cosine function may be presented as p over p power 2 plus omega power 2. Okay, so you see these two expressions, they have the same denominators, but their numerators are different. Here it's omega, here it's p. Let's proceed. Then let's present such a function as sinus omega t plus psi. It's common function. Let's present it. Let's use trigonometrical formula of sinus of alpha plus beta something omega t plus psi. It may be presented as sinus omega t cosine phi plus cosine omega t sine phi. It's from trigonometry. So let's apply here also a property of linearity. We have here cosine phi, it's just a coefficient, so it's cosine phi, yes. Then sine phi, it's Laplace image, it's omega over p square 2 plus omega square 2. It will be in denominator, so it will be just omega here. Omega from sine in numerator, it will be omega multiplied by this coefficient cosine phi. It does not depend from time, so it's just constant in the point of view from t and p functions. Then here we have sine phi, it is constant, multiplied by cosine phi. Cosine phi, it's p over p square 2 plus omega square 2. It the same, you see, the same denominators. And here we have p instead of cosine here, because it's in numerator, multiplied by sine. So we have such an expression to represent Laplace image of such function sinus omega t plus psi. k. Then let's consider function just phi of t equal to t. Let's to get its image by Laplace, let's integrate it by the parts. You see, it's for we should substitute here from instead of phi of t we substitute t multiplied by e in the degree minus pt by dt. So it is here. Then let's integrate it by parts. Let's present that t equal just here. Let's present that t it's function u, dt therefore will be equal to du. Okay, and we should write down first it u by dv, and dv here it will be next coefficient to in this expression. Integral minus pt multiplied by dt, it will be dv, and therefore v should be maybe got from here by integration it by time, and integration from exponential function is just exponential function, and it should be divided by this coefficient minus p to obtain such an integral. So we have this t by u by dv, it's here, and we should write down that such an integral when we take it by parts, should be known to you from mathematics. It will be u multiplied by v, it is here, with limits from 0 to infinity, it is here. You see, it's just u multiplied by v, it will be t multiplied by this expression, it is here, yes, and it should be written that it's equal plus integral from 0 to infinity of, it will be u dv, and here it will be v multiplied by dv. It will be minus minus u by dv uv minus v multiplied u multiplied by dv. It will be integral from 0 to infinity, and then we write down this expression minus before and minus here will give us plus. It will be 1 over p in e in the degree minus pt by e multiply by du, it will be just dt. Then this integral in these limits will be equal to 0. Why? Because when we substitute here infinity, this coefficient will be equal to 0 at t equal to infinity, and when we substitute this 0, this coefficient will be equal to 0, and therefore all this product of these two items will be equal to 0. So in both limits this expression will be equal to 0. So we will have to only this expression, and this integral equal to integral minus pt, it will be 1 over p should be divided by 1 over p, so it will be minus 1 over p squared 2, and when we substitute here infinity, this coefficient will be equal to 0, in the degree minus infinity equal to 0, and when we substitute this lower limit, it will be with minus and minus will give us plus. It will be just 1 over p squared 2, because e in 0 degree equal to 1. Therefore, image of function t equal to 1 over p power 2. And here let's consider it in the next lecture. It's such a function. It's alpha t minus 1 plus e to the minus alpha t. Sometimes such function can be, you can encounter with such function, and so I will explain you how it may be presented as Laplace image with the help of linear transformations. Bye for now. Don't miss next lecture, please.